Hi, I'm Simon Connell. So I have a professor position at the Department of Mechanical Engineering Science. That's at the University of Johannesburg. I'm actually a physicist by training, and I'm doing both physics and engineering. The physics spans from the ultimate structure of matter, and the engineering goes all the way to innovation, commercialization. So some of the students are in pure physics and some go all the way to engineering in our group. So people always say, what does a physicist do? We think that a physicist solves problems using basic physics knowledge. So we need to know how nature works, basically at a microscopic level or even at a particle level, or even more fundamental. So it's a very fundamental subject. There's a lot of mathematics to understand it. And then to percolate that up to the real world, we use computer simulation. So we do a lot of high performance computing. We do a lot of numerical modeling, and we look at how do our theories manifest up at the level, like this cup or something like that. But we have a deep appreciation underneath of the ultimate structure of matter. So some physicists are more theoretical. They maybe work with pen and paper. Others are experimental, then they have laboratories. Others are computational. And then there's the interdisciplinary side, that maybe you want to make advances in medicine, then you would team up with medical researchers and so on, material scientists, so on. It's very, very diverse. So there's space for everyone. Everyone finds their niche. How do they want to be a physicist in this system? So also you may be more in academia, and then we call it blue skies research. Very, very important, because innovations are going to come from your imagination. Like Einstein said, imagination's everything. So we maybe have some people that are involved in very esoteric things. Like I have one student that's probably our best shot at the Nobel Prize, is looking at entanglement and can you discover hidden dimensions with entanglement. So we think, yes, very esoteric, high-risk thesis. Maybe it's wrong and there's nothing there, but maybe it's right. And then it's fantastic and we actually can discover higher dimensions. But then we have the technology transfer from all of that. And we had the idea, probably I think it was 1998, for MinPET, this technology that we are commercializing at the moment. And in that idea was a way to visualize diamond inside rock. The same idea could be any mineral in another rock, or it could be something like cancer in the body. So engineers are very, very practical. They do subjects that physicists don't do. They do design, they do project management, they do risk analysis. So many technologies that have to be put together, and literally I would say in engineering is like you will find a mechanical engineer, an electrical engineer, and a nuclear engineer, but then you will also find a project manager. So interdisciplinary research is like the new high ground that everyone wants to get to, and promoting interdisciplinary research. And often when different disciplines come together, then you really get a lot of innovation. Yeah, so I grew up in Johannesburg. I never not remember being fascinated by science, especially by physics, especially by technology. I think I was always one of the best in maths and science in my class. So I always was good at it, and I attribute that because I love to do it. So my advice to young people, please only do your passion. Don't think who will employ you, what will your job be, because if you do your passion, you'll be able to do it so well that will make you the kind of person with the level of skill that someone will hire you. do your passion. Find out what you love doing, because that's the only thing that you can put in 110%.